We're going to do another example of a reaction, hydration reaction in alkene using hydroboration-oxidation. Let's remember that this goes AntiMarkovnikov, and this is also a syn addition, meaning that the H and the OH that you're adding across the double bond, those are to the same side. So let's do one problem here. And we have cyclohexene, but metal cyclohexene. So first thing that you need to know when you are adding, you know it is AntiMarkovnikov, but how do you know where is the H? Remember how you identify the more substituted and the least substituted. We're talking about the carbons, the vinyl carbon at the double bond. So here, this carbon has two alkyl groups, so that's more substituted than this one that has one alkyl group and one H. So this is the more substituted. And this reaction is AntiMarkovnikov, so here is where you are going to add the H. So if you add, say the H, I'm going to do it like, say that I put the H on wedge, and so I need to keep the metal on a dash. If you do that, because it is a syn addition, then the OH is going to be at the least substituted, but it needs to be to the same side of the H. So let's do that. So this is what we need to be adding, this and that. And again, the H to the more substituted, the carbon that has the metal, the OH to the least substituted, and they need to be added to the same side. What that means is if I had this in a plane, is I did the addition above, but I could have also done it the other way. So we are going to draw the other possible product. And so let's draw, you draw your cycle. And again, you're gonna add here, same thing, but if you're doing the H in a dash, you're gonna keep then the metal is gonna be on a wedge. And remember, if this is a syn addition, you need to put the OH on same side. So H and OH here are on the same side. So this is what you will do when you are predicting products. Let's do, I'm going to give you another example of that. Let's say now that I have the following molecule. And you see here that you had a D. So it is important to remember that when you see a D, D is an isotope of hydrogen, is deuterium. So chemically, we're going to think it behaves in regards to addition and other reactions, same thing. But we're putting a label. So, and it is important because here we need to determine, here I forgot to write the reagent. So this is hydroboration-oxidation. We're using the same condition, but I didn't write it on the top. Point is that here, we want to know which carbon is the more substituted and what is the least substituted. So think about the deuterium as if it was a hydrogen. It is a hydrogen, but heavier, a heavier isotope. So when you're thinking where do you put the H and where you put in the OH, then a carbon that has that D is least substituted, and the carbon that has the metal is more substituted. Again, think of these two being same. This is just heavier isotope, but it behaves in this direction similar to hydrogen. So what are we doing then? We are going to be adding H and OH across the double bond in AntiMarkovnikov fashion. So here you will need to add the H at the more substituted, the OH at the least substituted. I said it backwards. So we're gonna go then here, H at the more substituted. And to keep it like we have, say that I have a metal here, remember that there is a change of hybridization. This carbon is sp2. Now it's going to sp3. That's what I'm using here, which is in dashes here. This was in the same plane, the 3 bonds. So if you here add, say, the, that's some word substituted, you're adding the H, so keeping my, to keep track of where the H is that you're adding. Again, this is the least substituted, so you're going to be adding your OH here to the least substituted. Here, remember, that is this metal. And what is important to keep track is that OH and H are added to the same side. Typically, you will not see this drawn this way, but rather omitting the hydrogen. So, I mean, you will have this. But if you see this drawing, it's the same as that. If the metal is here on dash, that means the hydrogen is on a wedge. So you are on the same side. So this is the same as that. This is what you will be seeing. And of course, if you can add those to, say, the same side above the plane, or you can do it opposite. So we will have the enantiomer to that, meaning this will be, say, dash, and these, the metal here will be wedge. So the two chiral centers will have inverted configuration. So it is the enantiomer. Okay, so keep in mind then, where do you add? And if you see a deuterium, treat it as a hydrogen. So this carbon is the least substituted, that's the more substituted, and that is important to determine where you add the H and where you add the OH in this reaction.